Unit 3, Sensors and Vision Overview. We have finished the first half of the lab. The first half of the lab actually is on analytical geometry and the model for the robotics. Now we start the second half. It will be on control and the sensor and actuator. And here, Unit 3, we will cover the overview: digital sensors, analog sensors, camera and color, image subtraction and object localization, camera coordinates. So these are on the sensors. And we will also have the actuator portion. Overview. So here is the logical diagram for a robot. So basically your actuator controls the manipulator, and your sensor get the physical property from the environment, and you convert it to electrical signal, and then you send to controller and AI printer to make decision, and then send out the control signal to actuator and manage the manipulator. Sensors. Sensors take in the physical properties: temperature, location, color, humidity, pH value, the base and acid, speed, displacement, and there are many other physical properties that you can sense, you can measure. And then you send out the electrical properties such as voltage, current, resistance, luminance level of the light. And then you can send it as an analog signal for circuit to process, or you can quantize it by AD converter, analog to digital conversion. And then it will send back to the processor for digital signal processing. So for image processing, we have low-level process, mid-level process, and high-level process. And low-level is for noise removal and image sharpening. So this actually is usually for signal cleansing. And then mid-level, we start to try to get the attributes. So we try to classify some data. So there is object recognition or segmentation. So usually this part is just like edge detection, hole detection, something like that. And high-level processing will have understanding or navigation over the scene. So these are different levels for image processing. And we also have vision. Vision also have low-level vision, mid-level vision, and high-level vision. Low-level vision is to do coding on the AD conversion, so you get luminance, color, spatial frequency, temporal frequency, and the local motion. At the mid-level, you start to detect the texture, surface, lightning, global motion, and depth. And high level, you would get the characters, that's OCR, optical character recognition, or objects, or actions, or intentions. You make some decision and knowledge. So we may have an acoustic scene. We hear some audio signal, and then we recognize it, and we actually quantize it as bird singing events, car passing by events, footstep events. So these different events has logical meaning. And left-hand side, the acoustic scene has only the signal property. So later, we can find out at the lower level, we have audio input, acoustic sensor, and then DSP chip, and then speech recognition, representing different level of the representation of the signal and the electrical property. Voice recognition, you say something and you convert it to digital, and you use digital signal as information processing, and you find a pattern, or you do classification, and then you can control your dots, the Amazon dots or ecosystem, and then you can search through the internet. Purpose of sensors: to give robot information about itself, or to give robot information about the environment. These are the two purposes of the sensors. So basically, you sense the environment to avoid something, to advance over something, or you actually report your own status to your processor. Actuator. Actuator is the reverse operation for the sensor. So you get the analog signal from your processor, or you get your DSP signal from processor, and you convert it to voltage, current, resistance, or luminance. And then you control your actuator to make action. It can be mechanical operation, it can be chemical operation, and then it will change the physical property of the environment. So sensor and actuator in combine, also called transducer. It is conversion of the physical property to electrical property, or from the electrical property to physical properties. So here is a diagram for transducer. And usually you have a signal source such as speech, and you pass through transducer, creating electronic signal, and then go through the electronic processor, and then you actually transmit it through the internet using the modulation. And then the EM wave arrive at the receiver, and the receiver receives the signal, and then actually create the sound to the user. So basically you have analog converted to digital, then convert to signal, that will be analog again, and transmit through the channel, and the channel arrive at the receiver, and receiver convert it back to digital, and then use the conversion from the information back to the signal. Usually it's called synthesis, and then people will hear it. So this is the end-to-end model for a transmission of the audio signal from the signal source to the signal sink. End effector. In robotics, an end effector is the device that's connected to the end of the robot's arm end, enable the robot arm to perform a specific task. So basically, it is an important part of the end effector, and end effector usually will perform the actuator commands and actually manipulate or change your environment. Here is the model for robot models. So you have physical property converted to electrical property converted to physical property. And this model we usually call the end-to-end robot model. And right here, we do not have digital processing. So it's basically just signal conversion, and then doing some analog processing, and then converts back to the actuator and send back to the physical world. And you can have a DSP in the middle, so we can create feedback system. So basically you can control the sensor for tracking, or you can actually tune the parameter for actuator. So here I just draw a red color for the feedback portion. So you sense the physical property, and then you convert it to electrical signal, and that converted to digital signal, and digital signal processed by DSP processor, and then it create digital signal, and then it converted to analog property and control some circuitry, or actually control some mechanical parts, and then make the actuator to move, and then actually change the environmental properties. And if you add some AI learning portion, the diagram will be like this. You have physical property, you convert it by sensor to electrical property, and you convert it to digital, and then those data will be sent to the processor and also be sent to the machine learning portion. And then by the past data, you actually learn the model, and then you train from your learning model by the big data. And then you make the adjustment, you do auto tracking, or you do feedback, or you control your actuator. And with that, we call it a smart robot model. So basically, add in a learning model and using the past information to train your learning model, and then use that to control your robot to make more intelligent decisions. That is the end of this overview, and we do not involve any electronics. And in the next lecture, we will cover the electronics, and then we will go into some dry lab to show you how robot can be built. In the second half, we focus on the sensor, actuator, and also on the control and control planning. Thank you. Bye-bye.